We should be live again. Not sure what happened. That's unfortunate. But I didn't get too far. I was mostly just looking into this. This is creating a same foo. This would return false. This would return false. This is you loading in false. This is you creating a variable as false. You're ORing with false. 0 is 0, return 0, which is there. And then you're loading in 0. But anyways, this, we're checking this. We want to be loading in the opposite. If we do fetch exclusive OR, it is getting a value. Logical not. Hold on. This is what I want. This is what I want. Logical not with a Boolean value. Performs logical not in the current value and sets the new value to the result. That's what we want. Returns a pre-will. Fetch not. Fetch not. That just returns it. We want it to load. We want it to load the last value. Fetch not does just fetch exclusive OR. Isn't that funny? It's just the same thing. It's just the same function. Except you don't pass a value. In fact, I might just do that. But this is extra overhead, perhaps. The issue I have is it's not like loading it into what turn state should be. So maybe I need it to do fetch exclusive OR and then return state dot load, and we pass in this. Load a value from bool. Well, that panics if orders released are required. Do I just call the next function? I'm not quite understanding. I mean, all the examples are saying to do load here, and then they do order sequential. What was it? Sequential consistent operation. Is this what we want? I mean, I think so. Now it's gonna run an ad. I'm sorry, everybody. Twitch is gonna run an ad. Right integer. How can we fit this in? Well, we want this await keyword. Know that. So if we do spawner dot spawn, and then we do read earn button, and the buttons, we have a array that we create. Do I want to pass the array? I mean, I kind of liked this setup. This was very nice. Maybe I'd pass in the PCB. Ooh, this could get a little bit cheeky. Not gonna lie. Let's get rid of this. We're gonna pass in a mute PCB. Okay. No, actually not mute. Not mute. We're not muting anything. We're just checking. But we need to know what it is, of course. So we have a PCB. And in fact, I wonder if actually, I'm not gonna do that. What if I do buttons. I like to see keeping it separate. This. I think this we have to be different about. I think we do PCB. And if we don't do button, then we could do button inside of PCB dot. Oh shoot. We're not in an array. There's no array anymore. We need we can do an array. It's fine. I just need to make constants that define like 0 to white and 1 to black. So that way we can not have magic numbers. Let's do buttons. So bub buttons. And we're gonna do external input. We're gonna do this static, and this is gonna be 2. Then we come over here. Does that work? We need a comma here. Does that work? That looks like it works. We're gonna comment these out. Now we go to our implementation, and instead of it doing it like this, we do let white button. We'll do white button, black button, just like it is there, but instead we do buttons is equal to black button, comma white button, or the other way around, white button, comma black button. Does that work? Okay. Colon. Same kind of deal. External interrupts that have a unknown lifetime. That are two of them. No? Expected semicolon. Huh? I need it here. I think I need it here. Expected semicolon. The same song. I don't want the same song twice in a row. What am I doing wrong here? Does this need to be tuple? No, that doesn't make sense. Button. Yeah. Here. Buttons, external. Yeah, so what's the issue? I don't understand. Do I just do like without that? Like this? White button, comma black button? Doesn't look like it. Oh, we need equals. What if I did this? Does that equal anything? Nope. What if I did it as a tuple? Probably not. Probably not. Look at this. I'm just trying to battle the syntax here. Expected comma. Well, let's see the problem, and let's go to they don't have the compiler. What is the way you do this? What if I did this? Buttons, 0 equal to white button. Will that work? Buttons, 1 equal to black button. Okay. Oh, nope. Doesn't like that. Expected 1 of this. Found this. Okay. Problem. I just need to add this buttons. Oh, right. So we created... Wait, but okay. So it's saying we just do this. Buttons button 1? Is that? Yes. Cannot find value buttons in the scope. That's what I'm thinking. You just do what? White. Oh, that's not it. There's no way. Do I do... Oh, hold on. Is it this? I need to declare an array of external... Wait, didn't I do this? External interrupt. There's two of. Right? It wants the... Oh, lifetime to be undeclared. What's going on here? I think a Charlotte. I'm not looking for that. So silly. Do I? Huh? I'm sorry. What's wrong with this? Right. This is what I have up here. Oh wait. Equals white button, comma, black button, comma, and comma. Big problem. Expected semicolon here? How would there be a semicolon there? Here's what I mean. This is just me trying to figure out this silly syntax. I don't actually know what I'm missing. I guess we gotta look it up. First, we'll start with structs. Okay. Structs. Right? They made a new struct here. And you initialize the struct as follows. Struct is the name of the field and then a value. The name of the field and then a value. So what if instead I ask for one where they have an actual array in the struct? Does that ever exist? Does that sound like they're showing it? They're doing everything they can to avoid that exact use case. Interesting. Maybe I am the one who's thinking too much. Let me just quickly look. Rust struct. Rust struct with array. Array is a struct field. That's not what I'm looking for. This is more what I'm looking for. You can use a slice which requires a lifetime constraint. Some slices are not owned data, just borrowed. Ooh. That's a library. We're not looking for that. Every value needs to have a compile time known size. Okay. I'm trying to make it. It's right here. 2. Size is 2. Vals. Oh wait, that's their... No, that's just not a thing. Whoa. I didn't realize you couldn't really do that. You have to initialize your structure and arrays in Rust. So if you want an array of 10 cars, you have to write 10 car literals. Done with macros so that your code never ends up in a situation where uninitialized data could be used. For example, if your for loop did some non-trivial work and caused a panic in the middle of the iteration, that would leave your array with some uninitialized data. Huh. I'm surprised. I don't know what to think about that. I don't know if I understand it enough either. Do they have one with a tuplet tuple? Doesn't look like it. It looks like they're all single values. They need to break it down into button. Struct call a button. That doesn't make sense. The slice type. This is the slice type. Arrays are called slices. You're taking a slice of memory. I think that's my issues. I'm thinking of it as an array. Got the slice here. Grouping pieces of data together. Tuple types. Let's go to tuples. Maybe that's more up our alley. This is, they call it an array here, so there's still array. There's still arrays. Accessing arrays. Valid arrays. Oh. Just generic. Oh, that was all generic. I'm trying to see if there's anything else that I notice off about that. It's not quite looking that way. I'm just so surprised. If I did black button, what would happen? Right? Yeah, I shouldn't know that. Expected this struct, found this struct. What if I did like try to make a new one? Let's say I commented these two lines out, essentially copy them in. So they get initialized here. Change this to V15, this one to V15. What is our error? Expected semicolon? Yeah, that just wouldn't work. Found this. Nada. Okay. No big deal. We can just make it how it is, right? Got our two buttons. Got our two buttons. Black button. No, yeah, black button. I'm a white button. Got this PCB. It has each of those. Instead of button being passed in here, we are going to say PCB dot black button, wait for high, and we really, okay, yeah, we could just do this. Actually, we want white button because white button word. Oh yeah, true. It starts as true. We're going to turn it to false. We do want black button, actually. The reason is we want the thing to... Wait, that would make sense. When you start up, you first are getting white. Oh, we start with false then. We're exclusive ORing it with false, which should return true. And the next time you come around, you're going to do black button. Wait for high. Actually, what are we doing? We should just copy this. Black button. True. See if you're on the same page. If you do false again. So exclusive ORing your value true with 0, which will return 1. And then loading 1 back into it. You come down here. Now you need this to be true. You have to make it true. So you wait for a button to press. White is the button that gets pressed. Boom. You press it. You then go to the next area where you're exclusive ORing with 1. 1 and 1. Exclusive OR. It's loading. That value, which would be 0. 0 gets put into here. You wait for button press. Button is pressed. 0 and 1 would return 1. Need this. We have too many of these apparently, which is fine. Instead of button get level, we do PCB dot white button get level and PCB dot black button get level. This is so we can guarantee. What the heck? I don't know what that's about. This is so we can guarantee we are seeing the button presses. And then we're going to pass in PCB. Just like that. We pass in PCB, considering changing this to mutable. Okay, say I do. Then what? Mutable. Or actually I just do this because it is mutable. Have any issues? Nope. We have an issue down here. What's the issue? Borrowed of move value. And this is the classic problem, ladies and gents. This is the problem. PCB is being passed in over here. We can't do that. In fact, we actually don't need this code anymore. We can comment for now. We can't be passing in all the PCB. We can alternatively come up here and make some static variables, such as not even white button. We don't even need white button. We could just pass in these buttons without that struct. We could do kind of what's going on here, really. These two. Oh, the chat. Oh, it's overheating again. The Streamlabs camera thing. It's glitching out. Ooh, every time. Yeah, okay. We're just not gonna have chat in that window anymore. Yeah, something definitely messed up with that device. The Elgato tablet chat thing, no worky. All right, so I was taking care of something. So say we static white time, static black time. Actually, let's just write this out instead of writing them separately. Write the 1. So this is going to be a U32, atomic U32, new. That's going to be initialized to 500. And then we just copy this line and rename this to be black. Black time. Okay. So we don't have game state anymore, but we do have a PCB. And oh, that doesn't even solve our problem. Our problem is that we had too many things being initialized or passed around. So we kind of need this whole logic all over again. Just fine. Just a little sad. That's all. Instead of passing PCB here, you'd pass the 2 buttons. So if we do this, we are getting an error. What is this error? Value used here after moved, probably because of the PCB. We no longer need this PCB. We instead do this display, and then chess state goes away, this game goes away, PCB goes away, game state goes away, and then this gets changed to be the buttons. Can go ahead and what if we do this? Let buttons we're going back to this where we have our array of 2 buttons that are static now. And there's 2 of them that are equal to white button, black button, black button. Not, we just figure out what's wrong with it. We need square brackets. Okay, that worked. That worked. So buttons we can take and pass into here. And then we come up to here, change this to be buttons. That is same kind of parameter, external input. This will do like this. 2, is that right? Let's make this static maybe. Okay, yeah, that's fine. And then we go buttons 0. Button 0. That'll work. And in fact, we could probably loop through this, but we gotta be careful. There's like a paradigm that I recall reading on how you properly loop through the array in Rust. It's not quite your traditional way. Ooh, what section would that have been though? The Rustonomicon. Rustonomicon. That's not the book I'm looking for. This is the book. Ownership? Was it this? We need to figure out how to iterate. I think it's part of the functional programming area, actually. Collections, generics, automate tests, functional language. Here we go. And we just need to find one example. Here's a vector. Shirts. For shirts, use. Not used yet. Lists. That's not exactly what I'm looking for. How about we do this? Rust, traverse, traverse array, iterate array. Iterate mutable, enumerate. That's not quite what I'm looking for, but filter, not quite. Gosh, I wish I remember what it was. I wish I remember the exact wording that I was looking at. I mean, maybe it's in here. Yeah, it might have been this. The iterator trait. Save will interact with the iterator in several ways. By default, the for loop will apply the into iterator function to the collection. However, this is not the only means of converting collections into iterators. Into iterator, iterator, and iterator mutable. I'll handle conversions of a collection into an iterator in different ways by providing different views on the data within. Iterator borrows each element. Into iterator consumes the collections so that on each iteration, the exact data is provided. What's the two differences here? So they have 3 names in this names string. In both cases, they both iterate. They're using a match or a switch case. So they take Ferris. If it's Ferris, then print this. Otherwise, print this. Print the past name, really. In this case, they say borrow Ferris. And otherwise you print here. So why would you ever use this when you could just use into? Let's see. This consumes the collection so that on each iteration the exact data is provided. Once the collection has been consumed, it is no longer available for use as it has been moved within the loop. Okay, so this consumes it, meaning you can't use this names ever again. Intermute. Borrows each element of the collection, allowing for the collection to be modified in place. Okay, this is more what we want. This is what we want. But they have this reference again. Yeesh. Okay. So if I wanted to implement this, this just borrows it. Is this some? No, we want to mute it because we're going to be changing. No, actually, we don't want to mute it. It might need us to mute it. We are passing immutable, but in that for loop, it's going to get consumed. So we do for button, but no, let's do button in. We're not in, but yeah, in actually, yep. Buttons dot. Ooh, don't have any options about buttons. Buttons dot enter. No. iter. Oh, it's in the core. You can do it. Just wasn't imported right away. Should be imported now. Okay, well, it's not imported, but it's there. And then it's saying we need mute. Oh, no, iter mute. Oops, 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 oops. Hit the wrong button. Iter mute. Okay. So then we can do the address of buttons. Right? Oh, no, it's down here. So they're just dereferencing it. Name, not name, button, 0. That waits. Oh, actually, do we want a 4? We don't really need a 4, do we? We can do it like this. Button dot wait for rising edge. So we pause here, waiting for the rising edge. Oh, it doesn't like that. Cannot be dereferenced. You can't do that. This works. But it's saying that it would get lost. That's what I recall reading, is it would get reallocated. The mutably borrows each element. Does this borrow? This consumes. Okay, I guess this just borrows it. Okay, we can use mute then. Alright, anyways. Then we can just write this again. Println button level. And how about we do button number that, button number blank level is this. Okay, so we pass in button, 1, 2 in. Button gets passed in here, and then we also want to pass in the button dot get level. This might not compile because button is some random thing. Yeah, we can't do that. How about dot and convert it to a? No. Okay. Yeah, I mean it's fine. How about we do the state? Right, turn state. Doesn't like that. Format is not defined. Atomic bool. Oh. Oh, damn. Okay. We'd have to do some cleverness to get that to print it. That's fine. Do button level. Anything else we need? Oh, we need these. Do that, and then these can get reset. So theoretically, this should run every single time and get stuck here on this await, where it's trying to see if there's a button press or not. Which would get rid of these. So then what we're trying to do is see if it's turn state. Turn state, if it's false. Oh, hold on. Binary operation cannot be applied. We need to do turn state dot fetch or not fetch. We just need to see what it's equal to. Fetch update. Fetch and update would change its value. We don't need to change its value. So just a fetch. Fetch or? If you fetch or with 1, I mean that would tell you its value. So fetch or true, and we do, what is it called? Ordering acquire. When coupled with a load, if the loaded value was written by a store operation, then all subsequent operations become ordered after that store. Let's relax. No ordering constraints, only atomic operation. Oh, these describe how it operates. This is different than what I realized. Compare and swap. This one's acquire and load. Okay. Okay.